Okay, Chapter 8. Chapter 8 is linear regression, which is taking scatter plots and making more detailed analysis of it. So what we're going to do is we're going to start again with the data that we had last time, the SAT scores and the freshman year GPA. Again, you're going to be able to find this on the wiki for Chapter 8. It will probably be called data or something along the lines that will make sense with it. But we're going to start with the calculator. And if we look at it as is, and we stat and edit, I've got my data sets in L1 and L2, and from last time I still have the z-scores, but we're not going to worry about that just yet. Okay, I've got my data. Here's my freshman year GPA, or sorry, my freshman year GPA happens to be in L2. My SAT scores happen to be in L1. So what we're going to do is we're going to plot that. And I'm going to plot it in L1, and I'm going to plot it in, I'm going to make a scatter plot with L1 and L2. So I'll come down, here is L1 for my x-axis, here is L2 for my y-axis, and again, because I want my data to have, to be reasonably making sense, L1 is going to be my explanatory variable, which is going to be my SAT scores. L2 is my y-axis, which is going to be my freshman year GPA. And I'm saying that the L1, my SAT scores, is going to predict what the freshman year GPA. Explanatory response variable. And because my graph is probably wrong in some way because someone has graphed on my calculator or I've graphed on my calculator, I will zoom, stat, zoom 9, and I get that scatter plot. Again, let's talk about the description of this, the three things we need to talk about. Form or shape, it's linear. Direction, it's positive. And as X, which happens to be SAT scores, increase Y, which is freshman year GPA, also increases. And strength, it's 0.82. We saw that earlier as 0.82. But again, we're going to calculate that and verify that. So I'm going to calculate the correlation coefficient. So when I do that, stat, calculate, I'm going to do linear regression AX plus B if that's your choice, or number 8, linear regression A plus BX, which happens to be my choice, L1, comma, L2. And what I get from this information is I get, and because this is in A plus BX form, the statistician form, A here happens to be the y-intercept, B here happens to be the slope. I get my correlation coefficient, then I get that value of R squared, which is R times R. Alright, so looking at these values, I sit there and say, hey, there's my y-intercept. My y-intercept is negative 1.466. My slope is 0.0039. I could actually graph that line of best fit with that information. But again, copying this information down is going to be difficult, and then I don't want to have to do that. So conveniently, what I can do is when I make when I calculate this information the first time, what I can do is I can tell the calculator, hey, much like that, hey, I want you to put this information into Y1. Y1, the graphing of the line or the function, and just dump this in there so that it forms the equation for the line and graphs it, or makes it possible for me to graph it right then. I can do that. I can do everything all at once. So here's how we're going to do this. Start off again as stat and calculate, and we're going to do the exact same thing we did. We're going to do linear regression, and I'm choosing number 8, linear regression 8. And I'm going to do linear regression 8. Again, it's going to be L1, comma, L2. But then I'm going to hit a comma, because now I want to tell it where to dump that information to. And where I want to dump that information to is Y1. And Y1 is, again, it's a variable in the calculator. So where am I going to find it? I'm going to find it under variables. Where in the variables? Well, it's a Y variable. What a surprise. It's a Y variable right there. There's variables, there's Y variables. I'm going to go to Y variables. What type of Y variable is it? Well, there's three choices here. There's functions, which is going to include linear and exponential and quadratics. And then you've got parametric and you've got polar. And we're talking about just your standard graphing function. So it's a function. Hey, look, there it is. It's number 1. It's Y1. That's what I want. So I'm just going to hit enter, and I get L1, L2, comma, Y1. I hit enter. As far as I know, nothing has changed. I see the exact same thing I did. But if I go to Y equals, there's the equation. It's been dumped there automatically. So now if I go back and hit the graph button, there's the original graph, and there is the line of best fit. Yeehaw! It's the line of best fit. Now keep in mind, the line of best fit has 3 names. It's like gang names or aliases. It is called the line of best fit because it is the line that best fits this data. It is called the regression line because what we're doing is we're doing regressional analysis. It is also called the least squares line. That we'll explain later. So it's got one of these 3 names. Yes, you're going to be expected to be able to reference all 3 of those. So if it asks you for the regression line, the least squares line, or the line of best fit, you're going to have to know what that means for every single one of those, and they're all the exact same thing. So keep that in mind. Okay, so here we are with the line of best fit. Now, as we think about this, at some point you're going to be asked, and I'm going to quit here for a second, clear, to this data right here. There's my y-intercept, negative 1.4669. What does that mean? Now granted, we understand what a line of best fit is when we're talking about an algebraic setting. And the line of best fit is where that line crosses the y-axis, meaning when x is 0, y is this value. But when you're asked to explain this, you're going to be asked to explain this in context. In context means how does it relate to this problem? And you need to explain, well, what is x in our situation? X in our situation is SAT scores. So what that means is that when the SAT score is 0, the predicted, and we have to use the word predicted, the predicted freshman year GPA is negative 1.47. So that's what the y-intercept means here. If we had an SAT score of 0, which, by the way, it's impossible to get, at least as far, no, it's probably not impossible. It is impossible to get a negative freshman year GPA. In order to get a 0 SAT score, you'd have to work at it really hard because you get points for getting your name correct. And if you can't get your name correct, you shouldn't be taking the SAT. I bet they actually give you points just for, like, you know, if you would lick the paper, you'd probably get points for that so much. So you'd have to work really, really hard to get a 0 on the SAT. Anyhow, you're not going to get a negative freshman year GPA. All right, so what does this value as the slope mean? Let's think about what slope is. Slope is, and we're going to talk about this. What the heck is that? That's old stuff. Go away. Technical difficulties, we love them. Lots of old things. What slope is? And we're going to think about this algebraically. Slope is change in y over change in x. As we talk with apparently the really, really fat pen. Okay, change in y over change in x. Please don't use rise over run. I hate rise over run. That's great if you're in middle school. It's change in y over change in x. How does the y change compared to how does the x change? Okay, now our slope was 0.0039, but slope is a decimal. Sorry, slope is a fraction. I want to check the time here. Oh, we got 12 seconds to go here. Slope is a fraction. How do I take this and turn it into a fraction? Well, that's really easy. I can take anything and turn it into a fraction by placing it over 1. That actually happens to be how we want to do this. Should be playing, my timer should be playing music right now, and it's not. So we're at the point where we're going to pause and we're going to come back again next round.